check. All right, people, I believe we are live. Welcome back to Catalysis by Vedantu. My name is Pahul, and if you can hear me, if you can see me, please write yo in the chat box. You know what to do, yes. So people, today yet another class of ionic equilibrium, and I'll keep opening with this statement for the next few classes as well, because ionic equilibrium is a lengthy chapter. Now, if everything goes fine today, we will be done with the concept of solubility product. Solubility product is something that is very easy, but it takes a little bit of time to understand it, and if explained properly, it's a very easy concept. So I'll try my best to do so today. In the previous class, what had we done? We had looked at the concept of salt hydrolysis. Yeah, so previous class was salt hydrolysis. Today's class is going to be salt solubility. But as I told you in the previous class as well, the first 15 to 20 minutes of today's class will be devoted for salt hydrolysis itself. So I hope you have done your homework. I had told you to derive a particular formula, yeah, for a certain type of salt. Yeah, so without taking any further time, let me just show you what are these formulas. Let's just revise these ideas, and these are something that we have done in the previous class as well. Yeah, ठीक है. So दोस्तों, what's going on over here? First case that we had seen was weak acid and strong base salt. So this salt is going to be basic in nature. Yeah, CH3COONA, because the CH3COO component is going to go back with the H positive and become the weak acid, and your OH negative will be left into the solution. Yeah, so hydrolysis constant was Kw by Ka. H, which is the degree of hydrolysis, which I had explained to you briefly in the previous class. H is basically the alpha for a hydrolysis reaction. Okay, degree of hydrolysis is nothing but degree of dissociation for a hydrolysis reaction. So that can be written as root of Kw by Ka into Kc, but you don't need to remember it. Okay, there is no need to remember this idea. इसको कोई खास ज़रूरत नहीं है याद रखने की, because this is anyway something that you can solve it. So even if you don't remember it, it's fine. pH of the solution is very important, and we had derived the first two ideas. Yeah, we had derived the first two ideas. So half of pKw, which most of the times is equal to 7, because we consider our reactions to happen at 25 degrees Celsius. So isko 7 le lo chalega. So 7 plus half pK plus half log C, because this is a basic salt. 7 minus half pK minus half log C, because that is an acidic salt, the second one. Yes. So acidic hai, so you will be doing 7 minus minus. Over here you will be doing 7 plus plus, because it's a basic salt. So that's a way in which you can remember this formula. Okay, for a basic salt, yeah, salt that comes out of a strong base, 7 plus plus, other one is 7 minus minus. And now, my dear friends, the last type which hydrolyzes is the homework that I gave you: weak acid and weak base. See, it's going to be a very interesting combination of the first two cases. Yeah, it's going to be a very interesting combination of the first two cases. So if you do the analysis properly, when you write both of these reactions together, you would realize that the hydrolysis constant comes out to be Kw by Ka into Kb. Ka is the dissociation constant for the acidic part. Kb is the dissociation constant for the basic part. And when you do the further derivation, you realize that the formula over here is very simple. This comes out to be 7 plus half of pKa minus half of pKb. Isn't that pretty obvious? The good thing is there is no unit of concentration over here. See, concentration over here in this formula does not matter. When you do the derivation, you will realize dono concentration cut jayega. Okay, so the thing is, half pKa is with a plus sign, half pKb is with a minus sign. Do you realize why? See, when the acid reaction reverses, this will leave OH negatives and this will leave H positives. Do you understand? When the weak acid reaction goes backwards, it will give you OH negative in the reaction mixture like it did over here. And when the weak base component goes back like it did over here, it will give you extra H positives in the mixture, hence this particular formula. Okay, so no need to worry about this formula. You can try the derivation on your own. It still is a DIY thing for you. Do it yourself. You can easily find the derivation online. Everywhere it will be available. So try it out yourself. Okay, and this is the formula that you If you remember, it is good. If you don't remember, then at least try to revise this chapter thoroughly so that in the examination you can quickly derive the formula if the need comes. Okay? Chalo. Minav, nahi, yahi to baat hai. So Minav is saying, please derive and show. I tried, but it was difficult. Minav, that's the thing. If you give up, then there's no point. Okay? So over here, since you are saying it is difficult, brilliant. You do it yourself. Okay? If you do it yourself, then you will understand things better. Okay? So that's what I do as a teacher. If you ask me a doubt, 99% of the times I will ask you a question back. Okay? Because when you figure out things yourself, even if it takes 2 days, this grows, develops, right? If I tell you everything, then spoon feeding to yaar koi bhi kar sakta na. Yes. Chalo. Okay. Kaustav is saying, can we learn the formula for NEET? Absolutely, yes, you have to, my friend. Agar yaad rakhoge, to you'll be able to solve questions directly of salt hydrolysis. So now, people, I will frame a question for you. Okay. Now what I'll do is I will frame a question for you. It's a relatively simple question, but it again gives you a sneak peek to the world of titration. थोड़ा सा एक idea लग जाएगा titration का. Let me try to give you that question. Okay. 0.1 molar 20 milliliter CH3COOH was titrated against was titrated against 10 milliliter of, or इसको just to keep it interesting, हाँ यही कर देते हैं, against 10 milliliter of 0.2 molar NaOH. ठीक है? So what is being done over here? We are mixing two solutions. Don't worry about this word titrated against. Titration is basically just mixing of compounds in the laboratory in a certain manner. What is that certain manner? Why do we do titration? I will tell you in the next to next class. ठीक है? Most likely next class में ही हो जाएगा. So in the upcoming class of ionic equilibrium, I'll tell you exactly what titration is. But right now, I just want to ask you a question which is related to salt hydrolysis. You'll be able to solve it without knowing what titration is. So 0.1 molar 20 ml CH3COH was titrated against 10 ml of 0.2 molar NaOH solution. Okay. At the end, find the pH of the solution. As simple as that. Okay, and once again, the information that I give you over here is that Ka is equal to 1.8 into 10 to the power minus 5. Yeah, that is the dissociation constant for CH3COOH. Try it out. Okay, try it out, and what you can do right now in the chat box is try to tell me. Okay, try to tell me how to solve it. थोड़ा सा कोशिश करो in the chat box. Just try to tell me how we're supposed to solve this question. My biggest hint to you is it involves the formula, the concept of salt hydrolysis. करके देखो अभी. बहुत अच्छा question है. Simple. Minav Hall of Fame. Okay, I'll look at the Hall of Fame after this. ठीक है? Parshuram, anyone who wants to learn ionic equilibrium can attend the class, man. Yeah. Tyagarajan NC, there is a channel which Vedantu has opened called V Enthuse. Okay, and that is a JEE channel for physics, chemistry, and maths in English. So you can join that channel. Just write V Enthuse on YouTube, and I'm pretty sure you will be greeted with that channel. Okay, so यहाँ पे all the teachers are teaching in English. Okay, so Minav is saying, sir, by calculating equilibrium constant, we have to do that anyway. But what should be my first step? Yeah, think about it. थोड़ा सा बताओ. What should be my first step? चलो पहला step बता दो. For all of you who are getting an idea, okay, can you tell me what should be the first step to solve this particular question? बता के कोशिश करो. Kaustav, no, that answer is incorrect, brother. Aviral, for now, titrated against basically means mixed. Okay, as I told in the beginning of the class, titration is something where you mix two different solutions together. Why do you mix them? How do you mix them? I will tell you that later. For now, just assume that we are just mixing these two solutions together. Arijit, every day we've got classes from Monday to Friday at 7 p.m. for 11th class students, at 8:30 p.m. for 12th class students. Today at 8:30 there is a generic session which I'm taking. For daily schedule, you can follow the community page of our channel. We post the schedule every day. Batao, Devu is getting in the correct direction. Devu is saying find the amount of acid reacting with the base. अच्छा हाँ कर सकते हैं. Yeah. Find the amount of acid reacting with base. Okay, let's try to do that. Okay. See, this is simply an acid-base reaction. Do you understand? This is something that we have done in our mole concept chapter as well. Acid plus base. Yeah. So, first thing that we should do over here is let us analyze how much acid do we have and how much base do we have. Shall we do so? Moles of acid. See, the good thing is that I've given you a simple question. This guy is a monoprotic acid, yes? The equivalent factor of this acid is just 1. It's going to give you only 1 mole of H positive in the solution per mole of acetic acid, yeah? So, H positive, only 1 of it is going to come from this guy. OH negative, only 1 of it is going to come from this guy, yeah? So, equivalent factor for both the cases, the Z factor for both cases is 1. Yeah, if this was H2SO4, then life will be different. If this was H3PO4, then life will be even more complicated. Too complicated, in fact. ठीक है? तो यहाँ पे this is just CH3COOH. It's going to give you just 1 H positive. So how many moles of acid do we have in the beginning? Moles are equal to molarity into volume. Molarity कितना दे रखा है? 0.1. What's the volume? 20. कितना आ गया ये? 2 millimoles. Yeah. Understand, I'm writing millimoles over here because this is milliliters. If this was liters, then this would be moles. Yeah. So, molarity into milliliters gives you millimoles. So, this is the number of moles of acid. On the other hand, how many moles of base do we have? How many moles of base do we have? We've got 0.2 into 10, which is again the same. 2 moles. Again, 2 millimoles. Do you realize this is a very perfect situation? Yeah, this is a very perfect situation. Shall I write over here? You will have perfect, or I should say complete neutralization. Isn't it? There will be perfect neutralization over here. 2 moles of acid will very easily react with 2 moles of base to give you 2 moles of water and 2 moles of salt. Yes or no? So this is what's going on initially. तो यहाँ पे मैं लिख दूंगा initially. Finally, what's going to happen? This is just an acid-base reaction. So finally, when you do this acid-base reaction, what you will get is 2 millimoles of water, yeah, H positive plus OH negative will combine to form water, and CH3CO negative plus Na will give you 2 millimole of salt. What is this salt? The salt is CH3COONA. So this is the first step of this entire process. The first step is to figure out what is the quantity of the acid, to figure out what's the quantity of the base, see if it's a perfect titration. In this case, I've purposefully given you a complete neutralization because I want you to solve the question so that it's simple for you. Yeah, there can be incomplete neutralization as well. We will do that later. ठीक है, incomplete neutralization भी हो सकता है. We've actually done that type of a question in buffers. We'll do that again in titration. Don't worry. तो ये मेरे पास आ गई फाइनल सिचुएशन. 2 millimoles of water, तो चलो, no need to worry about it, let it be. Now, this 2 millimoles of salt, do you realize that this salt has the capability of getting hydrolyzed? Yeah. Our thought process over here is step by step. What we are saying is, first of all, the reaction happens, then the salt gets formed. This salt is the salt of a weak acid and a strong base. So this guy is going to hydrolyze. So using this piece of information, can you calculate the pH of the solution? Honest book review is saying why millimole. Honest book review, please go back and repeat your 10th class. भाई साहब, अगर आपको थोड़ा बहुत याद हो, listen to me carefully. Molarity is equal to moles upon liters. Okay? If I write millimoles, then this will be milliliters. What's the volume over here? Milliliters. This is what? Molarity. Get it? Please, basics of chemistry should be clear. If you're not good with the basics of chemistry, ionic equilibrium will be a very tough chapter for you. Okay, so I'm not telling you anything to discourage you. I'm just suggesting that please go back and revise the chapter of mole concept before you come to ionic equilibrium. Okay? Chalo. So please दोस्त मेहनत कर लो थोड़ी सी. Put some efforts into learning the concepts and calculations behind the chapter of the mole concept. The playlist is there on our channel. It's called the Epic Mole. Okay? चलो अब तो कर सकते हो ना इसको. So let's remove the unnecessary stuff on this page. Let's try to solve the question, and I'm waiting for you guys to give me the answer. Now you have enough knowledge about the question to actually give me the correct answer. Yeah, so I'm gonna erase all the pointless stuff. We just need to deal with this salt. ये salt से अपने को जूझना है. So my dear friends, again, if you remember the formula which we just discussed it, है ना? This particular salt is a basic salt. So the formula will be 7 plus half pKa plus half log of C. 7 का वैल्यू आपको पता है. 7 is 7. pKa value. This is the Ka. If you've been attending the classes properly, yeah, if you have been attending the classes properly, you would remember that if this is the Ka, then pKa comes out to be 4.74. Yeah, just 2 days back we used this value. There was a question where we were comparing a buffer solution of CH3COH and HCl with this concentration. Remember? So pKa is 4.74. तो यहाँ पे लिख दो value 4.74. What about log C? What is the concentration? Can you guys tell me what's the value of concentration over here? What's the value of concentration over here? That's the catch now. Yalanki is asking, is this lecture enough for JEE? It is enough only if you practice questions related to ionic equilibrium after this class. Ishani, no. Arey bhaiya, Ishani, how can the pH be less than 7 for a basic salt? It's a basic salt, right? Acha, sorry, you are giving me the value of the log C. Okay, sorry, my bad. Yeah, my bad. I think you are correct. Sorry, मैं कहीं कुछ और ही सोचने लग गया था. Very sorry. Yeah, so I think that should be correct. Kritika is saying 0.2. Moses is saying 0.2. Divyasa is saying 2 into 10 to the power 3. Cost of भाई log ले लेना इसका यार. Bro, take the negative log to the base 10 of this guy. You will get the pK. हाँ जी. This log C, how much should this be? I think Ishani is giving the correct answer. Tell me. पहले तो concentration बता दो. log C तो बात की बात है. What's the concentration? My dear friends, concentration is moles upon volume. What are the number of moles over here? 2 millimoles. What is the total volume? If you took 2 over here, incorrect. Question galat. What is the volume now? What's the final volume of this entire solution? 20 ml plus 10 ml. 30 milliliters. Milli se milli cancel. Moles upon liter is what? Moles upon liter is what? Molarity. 2 by 30 molar solution. ठीक है जी? 2/30 कितना आ जाता है, अब ये नहीं पता मेरे को. 1/15, 0.06 something. So yeah, I'm not sure if any one of you gave the correct answer to me or not. This comes out to be 1/15. You can do it as 1/15 as well. Log 15 ले लेना minus sign के साथ. That also works. You can write it as 0.06. Your wish. So ले लो इसका log. Take the log and then give me the final answer, please. What should be the final answer? 7 plus half into 4.74 plus half into log of 0.06. So this entire value, let me tell you, it comes out to be minus 1.2 approximately. Okay, this is a very approximate value that I'm giving you. तो क्या आ जाएगा यहाँ पे? You will have 7 plus 4.74 by 2 minus 1.2 by 2. So this is your final answer for the pH. Okay, this is your final answer for the pH of this basic salt. How much does it come out to be? बताओ कितना आ जाएगा? Gamer Boy Krishna is saying, what's your name? Gamer Boy Krishna, my name is undefined. My name is Infinity, bro. हाँ, ये तो कितना आ गया? Yes, so अब I can see people giving me the correct answer. Kumar Siddharth, very good job. And Krish, absolutely correct. Okay, Ishani, it's fine. It's fine. There are too many values over here. If your thought process was correct, great. Anyway, as far as I know, you're a doctor, so cool, bro. I mean, okay, only a couple of people gave me the correct answer. 8.77 आना चाहिए ना? Yeah, Ananya, absolutely correct. How will it be 8.14? Yeah, 4.7 minus 1.2 कितना हो गया? 3.54. 3.5 by 2 is how much? 1.7. So 1.7 plus 7 is 8.7. Yeah, so this answer comes out to be 8.7. Yeah, the answer to this question is 8.77 to be exact. Okay, got it? Divya Deep is saying it's a very difficult chapter. No, it's a lengthy chapter. It's not difficult at all. You're just doing equilibrium. You're just reacting two things together and doing equilibrium. People, do you understand what is this question comprising of? This, first of all, has a little bit of stoichiometry. Then it just has formula application. There can't be an easier question than this. If you find this question is difficult, I understand. You haven't spent enough time practicing the questions of ionic equilibrium. Spend more time. And I guarantee you, you will improve eventually. Silence Killer is asking how to join Vedantu crash course. Go down to the description box and open the link. ठीक है जी, चलो. Done. Understood this question. So what did we do? First of all, we saw how much acid and how much base is there, reacted it together, found out that we are getting a salt that can hydrolyze. This is a basic salt. Now all we needed to do was fill in the formula. 7 is a very simple value. pKa can be obtained from taking the negative log to the base 10 of the Ka, and log of C. Just need to be cautious about the concentration you're taking. 2 millimoles in 30 milliliters. Yeah. So 2 by 30 would be the molarity, and then you can solve this question very easily. Just simple plugging in of values. Okay. This is one of the easy questions from titration. There are some questions which are even more entertaining, but if you're able to grasp this idea, titration will be easy for you. ठीक है, चलो. So in case you guys want to see the explanation once again, just rewind the video and watch it again. That's the beauty of technology. You can watch things again and again. Now, let's come to solubility. Let's come to solubility. My dear friends, in nature there are different types of things. Some things are perfectly soluble. Imagine you're dissolving it in water. Yeah, very happily soluble. Some things are insoluble. Yeah, if I throw this pen in water, it won't dissolve. It's good that it doesn't dissolve. Yeah, if this dissolves in water, then abhi tak ye aadha ho chuka hota. Yeah, because there's moisture in the air. When we write, when we touch it, there's a little bit of sweat. This would have gone off, but it's insoluble. And then comes the interesting part where you are somewhere in the middle. My dear friends, a lot of things in nature are sparingly soluble. Do you understand the meaning of sparingly soluble? Sparingly soluble means not entirely soluble. Okay? If you add a salt to water, let's say it is a sparingly soluble salt. An example of that would be AgCl. Okay, so a sparingly soluble salt, when it dissolves in water, it doesn't dissolve completely. Some of it remains as salt, some of it dissolves. Okay, partially soluble can also be called sparingly soluble. इसको आप partially भी कह सकते हो. Yeah, and Minav is again reminding me to look at the Hall of Fame. So just write down and investigate the meaning of the word sparingly. ठीक है? चलो let me see पिछली क्लास में किसने सही आंसर दिया. Just 1 second, I'm trying to open that class. I'm trying to open it over here. Its comment section is not opening for some reason. क्या मजाक हो गया इसको. Just give me 1 moment. You write this down until then. Okay, something is very weird with YouTube today. Anyway, so sparingly soluble. Minav, I'll get back to the Hall of Fame very soon, don't worry. Rohan, increase the video quality to 1080p, my friend. Video quality यहाँ से बहुत सही है. Okay. Hoin Kyomai Singh, so what country are you from? I am not from this planet, bro. I am actually from the other galaxy. Fine. Sparingly soluble salts are salts that are partially soluble. So let us again take the example that I just told you, and that is AgCl. Now I'm not going to look at the chat box, let's focus on the class. AgCl, sparingly soluble salt. What happens when you dissolve it in water is that it forms Ag positive plus Cl negative. Now AgCl, as you would of course understand, is solid, and Ag positive and Cl negative would be aqueous. Yes. So this guy is solid, these two are aqueous. My dear friends, this particular reaction of dissolution of AgCl into water can also be considered as an equilibrium reaction. Okay. This particular reaction can be considered as an equilibrium reaction. So my dear friends, can we write the K equilibrium for this? And we'll see the significance of equilibrium over here very soon. Why should we consider this an equilibrium reaction? How does it work? What's the use of considering it as an equilibrium reaction? I will tell you very soon. But for now, can you tell me what will be the expression of K equilibrium? I'll write an expression, you have to tell me whether it is correct or not. K equilibrium can be written as Ag positive's concentration into Cl negative's concentration divided by AgCl's concentration. Is this correct or not? Just write correct, incorrect in the chat box. Batao. Yeah? Tell me. Is this correct or is this incorrect? Kaustav is saying with bold letters that it is correct. but Harsh says it's incorrect, Devu says it's incorrect, and some people are saying it's correct, some people are saying it's incorrect. Kostov suddenly realizes it's incorrect and says, no, it's incorrect. So, can anyone in the chat box tell us why is it incorrect? What's wrong? Harsh, very good job. Harsh is saying AgCl तो solid है, वो क्यों आएगा K equilibrium में? Very nice. Yeah. Jigyasu, yes, I was able to complete the backlogs on time. Yes, Aviral, absolutely correct. See, people, this guy is just a solid. And good, kudos to all of you who remember things from chemical equilibrium. In chemical equilibrium, we studied that whenever we have a heterogeneous equilibrium, okay, ये heterogeneous के spelling बड़े घटिया से होते हैं. Okay, whenever we have a heterogeneous equilibrium, all right, we need to consider only the phase that matters. Over here, the phase that matters to us is the aqueous phase. Yeah, aqueous phase is the more volatile phase. Solid phase क्या? Yeah, solid phase is not really going to affect the reaction. Its volume change is going to be insignificant. Its activity can be taken as one. If you don't remember this idea, you can go back to chemical equilibrium and revise once again. So in heterogeneous equilibria, we will take the phase that is experiencing the change. Yeah, solid phase में क्या change आएगा? So over here, we don't need to think about the concentration of the salt itself. How much salt have we taken? Doesn't matter. वो solid है, उसको भूल जाओ. Only take the aqueous part. Life becoming simple, right? Ionic equilibrium becoming simple. चलो, तो ये आ गया. My dear friends, instead of calling it K equilibrium, because we are scientists, because we are chemists, we want to sound smarter all the time, I won't call it K equilibrium. I will call it KSP. What is this KSP? This is known as the solubility product. Just to sound cool, okay? I just want to sound cool. So every K equilibrium that I see in life, I will rename it. I saw the K equilibrium for water, ionic product of water, better still, self-dissociation constant of water. I saw it for acids and bases, acid dissociation constant, hydrolysis product, कुछ भी बोलता है मतलब, yeah. So whenever you see a K equilibrium, you rename it to something that sounds fancy. Over here, we rename it to solubility product. Now, my dear friends, my question to you, I'm going to erase a few things, rewrite a few things, and then I'm going to ask you something. This product, okay, this product of Ag positive concentration and Cl negative concentration, is this going to be equal to the solubility product all the time? Is this the expression of K equilibrium all the time? Yes or no? Does this multiplication give me K equilibrium every time? Or no? Yes, Avril, absolutely. It's as simple. Solubility is very simple. Priyanshu is saying it depends on the extent of solubility. Nuti is asking, is this enough for mains? No, Nuti, I'm actually teaching students for nursery class. So this is not enough for mains. If you want to pass your nursery class examinations, then you should watch this class. So Balaji is saying no, it is not the KSP all the time. Nuti is also saying it's not the KSP all the time. Diksha is also saying no, it's not KSP, so on and so forth. Absolutely correct. This is not equal to KSP all the time. This is not equal to the K equilibrium all the time. This is basically just the reaction quotient, isn't it? Yes. This is just the reaction quotient. And my dear friends, let me remind you of something that we have studied in chemical equilibrium. Reaction quotient when less than K equilibrium. What happens? The reaction moves forward Do you remember how I told you to keep this in your mind? Just think of a bowl like this, and this is your Q, and the central point is your K equilibrium. Yeah. So if Q is less than K equilibrium, yeah, left side means less, right side means more, basic number line mathematics. So if Q is less than K equilibrium, reaction will go forward. If Q is greater than K equilibrium, reaction will go backwards. Yeah. So if Q is less than K equilibrium, reaction moves forward. If Q is equal to K equilibrium, then we call it an equilibrium. Okay. And if Q is greater than K equilibrium, then of course the reaction moves back. Right? Now, this idea is pretty simple for us to remember. We've studied it already extensively. But the thing is, how do we apply this idea to salt solubility? How do we apply this idea to salt solubility? How do we interpret this in reality? Like, what is my equilibrium? What is my reaction moves forward? What is my reaction moves back? Let me rewrite a few things over here once again. Instead of K equilibrium, since we are dealing with solubility, let's just write KSP in all of these cases. Solubility product, solubility product, solubility product. My dear friends, reaction moves back. What does it mean? It means that whatever is inside the solution is turning into the solid once again. Have you seen this thing happen in the laboratory? When you add two things into a beaker and then suddenly a solid appears. What do we call that process? Laboratory में कभी दो liquid आपने मिलाए हो और एकदम से नीचे solid आ गया, उस process को क्या बोलते हैं? बताओ. Pranjal, that's exactly where I am going. Kaustav, please revise chemical equilibrium. If you don't understand this point, please go back and revise chemical equilibrium, brother. ये पहले करवा चुका हूं मैं दोस्त तेरे को. You were there in that class, my friend. So Harsh is saying it's called precipitation. Precipitation. Dyasa is saying precipitation. Priyanshu is saying the same. Absolutely correct. Yeah. My dear friends, when two liquids combine together and give you a solid back again, how does that happen inside the laboratory? That solid just comes down to the bottom of the beaker, right? Sediments at the bottom. That process is known as precipitation. Yeah. If this product, if this reaction quotient in this particular case comes out to be more than the KSP, then you will have the presence of solid. Yeah, मैं यहाँ पे bracket में लिख दूँगा just for easier understanding that solid salt is also present. Yeah, equilibrium moves back, creates the solid. Yeah, and if you started with the solid, then the solid will stop dissolving at this equilibrium. Beyond equilibrium, the solid won't dissolve, it will remain as the solid. Are you getting some amount of idea? You start with the solid, it dissolves, it dissolves, it dissolves, it dissolves, then you reach equilibrium. Post equilibrium, beyond equilibrium, solid doesn't dissolve anymore. Solid now remains as a solid. Yeah. Beyond this equilibrium, when the Q becomes greater than KSP, solid doesn't dissolve anymore, solid remains a solid. Precipitation, solid is also present. So what am I saying to you? Equilibrium के बाद precipitation हो जाएगा. Beyond equilibrium, you can't dissolve anything anymore. What is that point of maximum solute being dissolved in the solution? What is it called? When there is a solute and you have dissolved as much of it as you can in the solution, what is that thing called? क्या बोला जाता है उसको? बताओ. बताओ बताओ बताओ. Ayush is saying it is saturated. Nidishwar, welcome to Catalysis. My doubt to you is, do you read the title of the video? It says lecture number 9. Please go back and watch the earlier classes. Please. ओके चलो, तो this equilibrium point can actually be interpreted as a saturated solution. Saturated. Equilibrium is when no more of this can get dissolved. If you dissolve any more solid, precipitation will occur. This is how we interpret equilibrium in reality. See, till now, how have we been imagining equilibrium? You've been imagining something, yeah, something like this, maybe water coming in, water going out, maybe some chemicals here, some chemicals here, all existing in the same concentration. That is just imaginary. Now is the time when we actually look at some real equilibrium. And what's this real equilibrium? It is the solubility of a salt. Yeah. At equilibrium, when Q is equal to Ksp, it is known as the saturated solution. Yeah. The point of saturation is signified by the K equilibrium over here. If you go beyond the K equilibrium, your solid is not going to dissolve completely. Some of the solid will remain. And obviously, now that we've defined these two things, what will be this? Yeah, Q less than Ksp. What is this case? This case is when you can dissolve more salt. Yeah, can dissolve more. Yeah, solution is not saturated. You can dissolve more salt. तो यहाँ मैं लिख दूंगा not saturated. Okay, so people, once again telling you that this is how we have to interpret. Okay, this is how we have to interpret salt and their solubilities. Okay, salt को जब dissolve करोगे, then you will check the reaction quotient. If the reaction quotient is less than the Ksp will be given to you. Okay, don't worry about that. Ksp is a value that will be given to you. If Q is less than Ksp, you can dissolve more salt. If reaction quotient is equal to Ksp, it is a saturated solution. And if you try to dissolve any more solid, it won't dissolve. Okay, Q greater than Ksp, precipitation will occur so that Ksp can be achieved once again. Okay. Is this page over yet? No. Because we are chemists, we want to make things a little more complicated. So instead of calling this Q a reaction quotient, I will give it a different name. Okay. Instead of calling it reaction quotient, I will give it a different name. I will call it ionic product. The product of the concentration of ions is known as the ionic product. यहाँ पे भी I'll rewrite things now. When the ionic product is less than Ksp, okay, when the ionic product is less than Ksp, you can dissolve more. When the ionic product is equal to Ksp, it's a saturated solution. And when the ionic product is greater than Ksp, precipitation will occur. Just name changes, okay? Reaction quotient for solubility is called ionic product, and K equilibrium for solubility is known as solubility product. Understood? The difference in the names is pretty obvious, right? Ionic product is product of the ions at any point of time. Solubility product is at the saturated point. Okay? As simple as that. So just write it down. In the meanwhile, I'll check if I can open the Hall of Fame yet again. कौन सा तो बाइक गया पता नहीं. It doesn't sound like a fast bike though, it's just a loud bike. If it was a fast bike, it would have gone faster. Anyway, so देखते हैं how many people actually give the correct answer. So the homework question was to give the formula for salt of weak acid and weak base hydrolysis, pH of that. So let me see how many of you have given me the answer. इसको मैं यहाँ कर देता हूँ. हाँ जी, so ईश्वर्या absolutely correct, good job. Ajita, log C नहीं आएगा. The concentration of the acid part and the concentration of the base part will cancel each other out. Minus हो जाएंगे दोनों एक दूसरे से. Try it out once again, okay? And Chandrika absolutely correct. Aviral, very good job. अगेन log C नहीं आएगा कौस्तव, try it out once again. log C नहीं आएगा लवन्या, yeah, log C shouldn't be there, log C shouldn't be there. Minav, absolutely correct, although you should try it again if you're finding the derivation a little difficult. Okay, it was given in the NCRT anyway, so you should have read the NCRT. Aman, yes, that is correct. Ananya, no, that's not correct. Yes, Ayush, absolutely correct. So Ayush, I think he's tried to derive it here as well. Very interesting. Ankit, no, that's not correct. Divyansh, we'll look at your question later. And Krish and Shali, incorrect answers, but don't worry. Try it out once again today, okay? Try it out once again today. The concentration that you take for the acidic part and the concentration you take for the basic part will basically cancel each other out. Try करके देखना, हो जाएगा. Okay? चलो जी. So this is about solubility. There's one more thing remaining in solubility. Okay, एक और चीज बची है solubility में, वो भी कर लेते हैं. Understood this part? If you need more time, just pause it. If you need the explanation once again, rewind the class and watch it again. Let me tell you something more about solubility. Okay, अच्छा चलो. तो let us say initially I take concentration A. Concentration क्या है? I take amount A of AgCl. Do I worry about the amount of AgCl? No. क्या फर्क पड़ता है? Take how much salt you want. In the equilibrium, this guy is not going to be there. So at the end, let's say finally, okay, finally once you are done with the jazz of solubility, what will happen? This will be A minus X, this will be X, this will be X. In this particular case, my dear friends, can I simply write X square is equal to KSP? Everyone understands this jazz? Yeah. Basic stoichiometry plus chemical equilibrium here. Nothing complicated about it. It's just that it says positive and negative. That's why we call it ionic equilibrium. Otherwise, this is basic chemical equilibrium. Yeah. So X square is KSP because this thing is solid. So we don't need to take into consideration this amount. Everyone should understand this. Okay? Vivek, just an example that we are taking, bro. Why did you join the class half an hour, 40 minutes late? It's like all of us are sitting together and we are having a conversation and we decide that we all are hungry, so we will order pizza. After we are almost done with pizza, you're coming in and asking, why pizza? Why didn't you have rajma chawal? Arey bhai. We've already discussed that idea. Please join the class on time or watch it from the beginning. Interesting. Okay, so X square is equal to KSP. But since we are chemists, can we leave it so simply? I don't want to. I will not leave it so simply, okay? इतने आराम से तो मैं छोड़ने नहीं वाला. So instead of X, yeah, because I told you in the previous class, forget your X. So just kidding, just giving you something funny to relate to. So now instead of X, I will write S. Just want to be sophisticated. Sophisticated starts with S, so I'm gonna write S over here. S square. Yeah. S is equal to, I don't know how to write the letter S. S is equal to root of KSP in this particular case, yeah? My dear friends, welcome to ionic equilibrium. We will give it a different name. We will call this solubility. This value S is solubility. बस खत्म. Minav, I guess, yeah, pretty much. कौस्तव, मुझे भी भूख लगी है दोस्त. But do you get it? What we just did? S equal to root of KSP, खत्म. Okay. But is this formula always gonna be true for calculating solubility? So what they will do is they will give you a sparingly soluble salt. They will give you some details about it, and then they will tell you calculate the solubility. Yeah, so you will have to plug in all the values, calculate the solubility, which is this letter S. My question is this formula always true? No, of course, if I'm asking you, there has to be a catch somewhere. Yeah. So what do you think? Is this formula always true? And if it is not, just try to imagine when it won't be true. I will give you an example just now. Devyansh, that's the beauty of being a chemist, man. You get to learn. Okay, fun fact for all of you. In this world, whenever you do a specialization in something, let's say you become an MBA, you become a master in business, yeah, you become a master at something. Half of the job of becoming a master at something is to define these terms and remember them. That's how our education system works, okay? तो MBA में ऐसा ही होता है. MBA में what they'll do is they will bring you to a class, and if I ask you, okay, that let's say you're opening a new shop and you want to make a profit of 5 rupees per item, so what will be the cost of item that you'll sell? So you will easily say कि हाँ, I'm able to make the item at 10 rupees, so I'll sell at 15 rupees to get the 5 rupee profit. In MBA, they will give it different names: profit analysis, cost benefit analysis, return over investment, etc., etc. They'll just give different names to the basic logical stuff out there. So a lot of specializations just are about remembering names, except being a doctor, of course. When you are a doctor, you have to practice medicine. So chalo. This, of course, is not always true. Yeah, this of course is not always true. So let's take another example. Yeah, एक अलग example लेते हैं, and let's take an imaginary salt. लेंगे? Let's take an imaginary salt. Let's take A3B2. या चलो AlCl3 ले लेते हैं यार. Okay, imagine that AlCl3 is a sparingly soluble salt. Let's take this as an example. So my dear friends, when it equilibrates, what will it form? It will form an Ag3 positive plus it will form 3 times Cl negative. So if initially this is A, finally this is going to be A minus S, this is going to be S, this is going to be 3 times S. Stoichiometry, if you consume S amount of AgCl3, you are producing 3 times the chloride, 3S. Yeah. So over here, can I write 3S cube into S? चलो step by step लिखते हैं. Over here, what is the equilibrium constant? Cl negative concentration cube into Ag, sorry, क्या है? Al. मैंने सिल्वर को लिख दिया. My bad. Al3 positive concentration, just a tiny silly mistake I did. So Cl negatives concentration to the power 3, Al3 positives concentration to the power 1. This is going to be equal to your solubility product at equilibrium. This will be your Ksp, or I shall just write ionic product in general cases. Let's think about equilibrium, Ksp, this particular case. Cl negative concentrations cube is how much? 3S cube. This is simply S. This is equal to Ksp. So my dear friends, from here, what is the value of S? From here, what is the value of S? इसको मैं निकाल रहा हूँ यहाँ से जरा. So from here, I can say that 27 S raised to the power 4 is equal to Ksp. So over here, the formula of solubility is different. So depending on the number associated, okay, depending on the stoichiometry of the reaction, the solubility's relation with Ksp changes. बस ये ध्यान रखना है आपको. Okay? Okay, that's all you have to worry about. I mistakenly took silver over here instead of aluminium. My bad. Cool. So this will have a different ball game in the question altogether. Let's try to do a question now. Enough talk. ये बता दिया मैंने. ये करते हैं. Calculate the solubility of MgOH2 in H2O. Ksp is equal to this much. Very simple question. Yes, I will do it along with you. साथ साथ में करते हैं. MgOH whole twice, when it breaks apart, is going to form Mg2 positive plus 2 times OH negative. Initially this is A, finally this is A minus S, this is going to be S, this is going to be 2S. So from here can I write 2S square into S is equal to KSP? Yeah, simplify करते हैं इसको. I can write over here 4S cube is equal to KSP. What is the KSP value that is given to you? 1.2 into 10 to the power minus 11. Yeah, or I can simply write it as 12 into 10 to the power minus 12. Yeah, लिख सकता हूँ. Just multiply, divide by 10, you will get this value. So यहाँ से कट के हो जाएगा 3. S comes out to be 3 raised to the power 1 by 3, basically the cube root of 3, interesting, into 10 to the power minus 4. You can calculate the cube root of 3 if you want. Awesome, pretty simple job. कैमरा हिल गया क्या? अरे कैमरा, हाँ यार पता नहीं कैसे हिल गया ये. भूत भूत आ गए क्या आज? आज तो बिल्लियां भी अंदर हैं रूम के. Yeah, okay. Thanks for the warning. I think when I kept the bottle, it moved the wire of the camera. पता नहीं क्या चल रहा है. Anyway. So, cost of, yeah, right. So this is done. Simple question. Let's try another one. ये आ जाएगा जो भी घटिया सा है, बाहर में जाएगा. Okay. A mixture of water and AgCl is shaken. ये बहुत अच्छा question है. Okay. Let's try to do this question and then we will end today's class. A mixture of water and AgCl is shaken until a saturated solution is obtained. Then the solid is filtered out and 100 ml of the filtrate is added to 100 ml of 0.03 molar आना चाहिए यहाँ पे, ठीक है? तो 0.03 molar NaBr. Okay. Should a precipitate be formed? Very, very, very nice question. काफी मजेदार क्वेश्चन है. स्टेप बाय स्टेप करेंगे एंड दिस विल बी द फाइनल थिंग दैट वी डू इन टुडेज क्लास. रीड द क्वेश्चन, आई विल गिव यू 5 seconds, देन लेट्स डू इट. Cool. ठीक है, चलो. तो what's going on over here? Let us try to see what we have. We have, okay, we have a saturated 100 milliliter solution of AgCl. And what we do next? Okay, ये है अपने पास saturated 100 ml saturated solution of AgCl. So that line is just pointless jazz कि mixture लिया, ये किया, वो किया. At the end you just have a 100 ml solution of AgCl that is saturated in AgCl. पूरा AgCl जितना हो सकता है भर दिया उसमें. Then second is you add 100 ml of 0.03 है ना, 0.03 molar NaBr, and you should remember that sodium bromide, like sodium chloride, is a strong electrolyte, so when you dissolve it, it will break apart entirely. Once you do these two things, you have to figure out whether a precipitate can be formed or not. Now there is some missing information that I will give you. Just give me 1 minute. I will give you the missing information very quickly. Just 1 second दे दो मेरे को. The solubility products are not mentioned over here. तो मैं एक बार ही निकाल के देता हूं आपको. In the question, if it comes in your examination, they will mention the solubility product. No need to worry, you don't have to remember it. अच्छा, solubility product को याद नहीं रखना आपको, वो जब आएगा क्वेश्चन तो आपको दे के रखेंगे, यहाँ पे गलती से मिस हो गया है. So just a moment, I am trying to see what are the values. Okay, just another second and I should have the values in front of me. कहाँ चला गया ये सवाल? Yes, I have the solubility products in front of me. Let me give it to you. So what will be given to you in the question is KSP of AgCl is equal to 1.78 into 10 to the power minus 10. Okay, this is one piece of information that is given to you, and the second piece of information that is given to you is KSP of AgBr is equal to 5.4 into 10 to the power minus 13. ठीक है, ये दे रखा है अपने आपको. ये this is the information that is given to you and this is what you've done. So my dear friends, let's try to do this question, and I think I can give it to you as a homework because it's already 8:03. So let me give you a hint of how to solve it. Number 1, find concentration of Ag positive and Cl negative. How will you do this? By using the solubility product, है ना? Then what you are doing is you're basically turning that solution into 200 milliliters. Initially it was just 100 milliliter of solution, now you're turning it into a 200 milliliter solution. So first just calculate the concentration of Ag positive and Cl negative using the solubility product. It's a saturated solution, it's an equilibrium solution. You can use the equilibrium constant to get the concentration of Ag positive and Cl negative. Yeah, S square is equal to this. S आ जाएगा, S will be the concentration of Ag, S will be the concentration of Cl negative. So first of all, try to find the concentration of Ag positive and Cl negative. Second, after mixing, okay, after mixing, find new concentration of Ag positive, Cl negative and Br negative as well. ठीक है, 100 ml का 200 ml हो गया. So of course the concentration will be different now. Yeah. So calculate the new concentration of Ag positive, Cl negative, and also calculate the concentration of Br negative in the solution. NaBr will break apart entirely, so you will have 0.3 molar NaBr that is breaking off. Calculate the concentration of Ag positive, Cl negative, Br negative. Then try to multiply Ag positive into Cl negative. If it is greater than KSP, precipitation will occur. Try to take the product of Ag positive and Br negative. If that is greater than KSP of AgBr, then precipitation will occur. So that is how you have to check whether a precipitate will be formed. And if yes, which precipitate will be formed. So this is your homework question. Okay, so our next class is going to be tomorrow at 7 p.m. We will do a few questions of the solubility product and then we will get into what are indicators, what is titration, etc, etc. So kal ki class is going to be dedicated more towards titration and indicators, but first we will practice some questions of the solubility product. ठीक है? Got it? So this is your homework. Next class is tomorrow at 7 p.m. You have to give me the answer. Should a precipitate be formed? And if yes, which precipitate will be formed in this case? I have given you the hints of the question that are necessary to solve it. Cool. आज थोड़ा लंबा चला गया class, but I still hope you enjoyed it. If you enjoyed the class, make sure you hit that thumbs up button because अच्छा लगता है likes देख के. Everyone likes likes. And another thing, in case you want to join Vedantu as a long-term student, if you want to join our patented platform with amazing teachers, amazing content delivered to you, all question banks will be given to you if you enroll into our regular classes. Links for that are in the description box down below. You can enroll for a crash course of JEE 2021 as well if that is what you need. Again, links are in the description box down below. Cool. So people, that's it from my side for today's class. थोड़ा लंबा खिंच गया है. So I'm going to see you now at 8:30. It's a general session where I will tell you something very nice. It's something that brought a smile on my face a few days back. So I'm just going to share that information with you at 8:30, and then we will just chat casually in that session for some time. Cool. So people, thank you so much for joining in, and yeah, hit that like button if you enjoyed it. Stay subscribed because tomorrow we've got the next class of this chapter. Until next time, take care. Bye bye.